Welcome along to the Met Office Deep Dive. Thank you for being there. I hope you're not put off by how long this deep dive is. Don't get too scared. It's not going to be all about the weather for the next few days, although there's quite a significant chunk of that. But this week's deep dive is a special. We've kind of done it in two bits, really. Later on, I've got a very special guest, Mylne, coming in to talk specifically about Ensembles. So that's kind of the second half of the deep dive. The first half will be the usual stuff, tucking into some juicy meteorology, and there's plenty of that over the next few days. It is going to get colder at the weekends. There's a lot of talk of snow. We'll break down the chances of seeing anything significant as well. Thank you for being there. Thank you for watching. We love reading your comments, so if you've got any comments, any questions, then do pop them in the chat, and do give us a like, and tell other people that we're here. Let other people know that the Met Office do this every Tuesday. And here's a new thing that we've just started doing as well. Did you catch us on Friday in the live? The Weather Studio Live was back last Friday. Aidan and I chewing the fat, and it's going to be back this Friday as well. So that's another thing to add to your schedule. If you subscribe, you'll get notified when we go live. And we're going to do that every Friday from now on. One of the things we were talking about, that was how gloomy and how dull it's been so far through November. And I've got some interesting stats to show you for today. This is the sunshine map, or rather the lack of sunshine map for the first 11 days of November. Now, this is showing sunshine compared to average for the whole month, so you wouldn't expect it to be anything other than a little dull, but this is exceptionally dull, with pretty much all parts from southern Scotland southwards less than 30% of their average sunshine. You would normally expect around 37%, so you would normally expect it to be in this mid-shade of grey, and parts of central Scotland are in that, and parts of northern Scotland are above that, because northern Scotland last week, while much of the rest of the UK were suffering with the anticyclonic gloom, they were poking out into the sunshine. So it has been a sunnier than average month across northern Scotland, but much of the UK has been distinctly grey, distinctly lacking in sunshine. But it has also been quite mild by day, but particularly by night. That blanket of cloud last week really kept those temperatures up at night. Now, this is the rolling temperature as we go through the month, dates going along the bottom, and the extremes. So the warmest is that orange line at the top. The coldest ever recorded is this blue line at the bottom, and this thicker blue line, that is this year. And you can see that until yesterday, we were actually above the warmest on record. These were the minimum temperatures across the UK as an average. And just with some colder conditions spreading south and some clearer skies arriving, we have seen those temperatures dip down below that record, but we're still in a pretty exceptional area at the moment. For 11 days in, we are significantly above this average line. So it has been a very mild month, particularly so by night, and it has been a very dry month as well. That high pressure that we've seen dominating, keeping a lot of cloud but not generating much in the way of rainfall. In fact, the driest start to November on record, beating the previous record as we stand 11 days in, which was I think 1964. So it has been very dry when you compare it to the average. That's this middle line here, and again you've got the extremes, the wettest November there and the driest on record, that pale blue line. We're just below that at the moment. Now, things are going to change, the weather patterns are shifting, but just to show how incredibly dry, how mild it's been at night, and how very dull November has been so far. And this is, what, a third of the way through the month, slightly over. So it has been a pretty remarkable month so far. But we deal in forecasts here, so how are things going to change? Well, they are going to change, quite a bit, quite significantly in the next few days. Here's the satellite image for the past few days, and you can just envisage that chunky area of high pressure sitting here. Weather fronts have been trying to push in. You can see the bands of cloud have been trying to make progress in across the UK and not really succeeding. But we are going to start to see a change, not necessarily from the west, but more from the north. Let's take a look at what the jet stream's doing. going way up to the north, bending back round and down here. We've seen more unsettled weather across Iberia recently, and as the jet stream drives in here, there's a low pressure high in the sky up here, and it's squeezing against this block, this high pressure that's dominating, keeping things largely dry. But where we've got them squeezing together, we've actually got quite a few shower clouds moving in across the southeast of England. We've seen some wet weather drifting in here over the past 24 hours or so, and you can see them here, the showers just zipping in across parts of East Anglia and the southeast through the day today. But high pressure in control, and as we go through the next few days, well, we're not going to see a great deal of change. The high continues to dominate. A weak weather front topples in around it. We lose that jet coming down across the southeast. There's not as many showers across the southeast tomorrow, looking largely dry, but still quite sunny. Under the axis of the high, so close to the centre of the high, that's where we're most likely to see some fog. So like last night, again, parts of Northern Ireland could see some fog, southern Scotland, northern England as well. As we go through the next few days, well, not a great deal of change. The high pressure continues to dominate. Let's put it on the bigger picture. Take the jet stream off because that's not really doing a great deal. High pressure, high pressure, high pressure, until we start to see the high actually waddling back this way, and this is going to mix things up. It's a cold front, as you can see, and that's really going to change things up as we go towards the weekend and introduce colder air, because it is a cold front. Let's put the temperature profile on. You can see the colder air lurking up here. We'll put the jet back on because it's this dip in the jet stream that's driving this area of low pressure, generating it, pushing that further north, and then you've got quite a contrast in temperatures here. That's the cold front, and this jet stream will push that south, and all that cold air is going to flood south as well. There is a bit of uncertainty as we get to the second half of the weekend, but until then, let's take the jet off again and just walk through that period as we go through Wednesday, Thursday, Friday. High pressure, still most places dry, variable amounts of cloud, and then zooming in, here comes that cold front. Look at that cold air drifting its way steadily southwards across the country, introducing much cooler conditions by the start of Saturday across Scotland, Northern Ireland. But we'll all be in that colder air, we'll be post-cold front by the time we get to Saturday evening. That rain will be clearing through. There'll be some rain on it, but not a huge amount. But, you know, any rain significant because it has been so very dry. But there's the colder air coming into play. It's not going to go any further into Sunday at this stage because, yeah, things get quite complicated for Sunday. But let's focus in on that colder air coming in because it's really going to change things up a little bit. If we take a look at the temperatures over the next few days. Not that one, it's that one, isn't it? Still not quite got used to the new touchscreen as we look at it, but actually temperatures by day for the rest of this week, pretty much bang average for the time of year, 9s, 10s, 11 degrees Celsius. Obviously, if you've got fog, then those temperatures are going to be suppressed, and that's what's happened today and could happen again as we go through Wednesday. Stubborn fog patches will really suppress those temperatures, but whether it's sunny or whether it's cloudy, kind of 9, 10, 11 degrees Celsius is pretty much what we're looking at. By the time we get to Saturday and Sunday, notice those temperatures are coming down, so we're looking at single figures on Sunday, pretty much across the board, although again some uncertainty about exactly how quickly that cold air stays in. But you can see the trend there to those temperatures dipping away, and if we put the minimum temperature on, you don't get as much of a range here because as we see the colder air coming in, there will be still quite a lot of cloud, and we've got the clearer skies at the moment. That's where we're seeing a touch of frost, so it's not as obvious, that temperature dip in the nighttime values. It's much more obvious in the daytime temperatures as we see that colder air coming in from the north. So the first thing in the morning, you may not actually notice too much of a difference. The past couple of mornings have been colder because we've had the clearer skies compared to last week when we just had the blanket of cloud keeping those temperatures up. So interesting to see there how the temperatures by night don't really change a great deal. As we go into next week, we may see something a little bit lower and those temperatures could be falling down. But generally speaking, the next few days, as I say, we'll keep high pressure in control, a lot of dry weather. There's that weather front moving in. And if we take a look at that in more detail, let's zoom in a bit across Scotland. There is that weather front, and it will bring some significant rain after a very dry spell. I know some places actually still struggling because October was so wet, or it was a very wet start to autumn. So even though it has been very dry start of November, there's still a lot of groundwater in some parts of the country. This rain is going to come in, and you can see that narrow line on it there, just a really narrow line. So a sudden burst of heavy rain. We call that, could be a squall line, where the winds will also suddenly change direction. You get a rapid switch in wind direction. The rain won't last all that long, but it could be really intense for a while, and the winds will suddenly start to gust up. So this is on Friday afternoon to Friday evening. That sinks its way south. There's a pretty narrow band there across Scotland. So the rain's not going to last too long, but nevertheless, it will bring some heavy bursts of rain for a short period of time. The winds really suddenly pick up on that. You've got that complete change in wind direction from a southwesterly to almost a northwesterly there in a matter of minutes, really. So a swing in the wind direction, some gusty conditions as that band of rain sinks its way southwards. And then obviously it continues to push its way southwards, and then lo and behold, is that the first flurry of snow I see on the chart there? Well, not really, because we had some a few weeks ago. We've seen some snow on the Scottish mountains already, but you know, the first kind of significant on the chart there, seeing a little bit of snow, but it is mostly going to be up over the hills. Something that Aidan showed, interestingly, on the Friday live last week was the freezing level chart and how it was particularly high across the UK, and that is still the case at the moment. So the freezing level, shown here in dark green here, is above 1,400 metres, and that is basically, the freezing level is how high up in the sky you have to go before you get to zero. And that is significant because that kind of determines the type of precipitation that you see. If it's below freezing, then it's going to be snow, broadly speaking. If it's above freezing, then it's going to be rainfall. So you've got to go right across the UK, you've got to go up through the sky at least 1.4 kilometres before temperatures are even close to freezing. And Aidan actually showed a map. It wasn't just across the UK that the freezing level was particularly high, it was right across Europe. But obviously with that colder air coming in, this is going to change. So let's look at that change, because it's quite a significant change. It's quite a flip as we go through Friday. As that cold front comes in, just look at that colder air coming southwards. So you can see that there, by the time we get to Friday night, start of Saturday, we're now into the blues. So the freezing level has dropped from above 1,400 metres to less than 1,000 metres, 800. In fact, some elements of 400 metres there, just off the Northern Isles. So that freezing level is coming down. That's indicative of that colder air that you now only have to go up 400, 500, 600 metres before you get to zero. And that colder air, that colder air mass sinking right the way south. Look at that. Isn't that a thing of beauty? Just whee! Oh, I could do that all day. Look at that cold air flooding its way south, so that by the time you get to the early hours of Sunday morning, much of Scotland is covered in that, where the freezing level is only 400 metres. And large parts of Scotland, obviously the mountains, most mountains are above that kind of height. Now, even when the freezing level is 400 metres, it doesn't mean that you get snow at 400 metres and anything below 400 metres is rain. The snow can still fall through temperatures that are a little bit above freezing. So when the freezing level is about 200-300 metres, you can still get snow down to low levels. And we're kind of talking about 400 metres. That's the lowest. Not a lot of greys on these charts. More like to get that in proper winter. Obviously, we're still only in the autumn months. So it's not exceptionally cold, but it is much colder air than, of course, we've been used to. But that snow level, that 0 degree Celsius level dropping to about 400 metres, which means there is the possibility that some of the snow flurries could get down to lower levels. Not likely to stick, not likely to cause much in the way of problems, but certainly over the hills with that kind of air, we are going to see some snow showers coming in, and that's what we're likely to see as we head towards, get the right chart up, is that the right one? As we go towards Saturday, there we go, you can actually see some snow there building up. So this is the 3-hour snowfall totals across Scotland. It is only really across Scotland. It is really only across higher ground. You could see some flakes at lower levels, but it's not expected to cause too many issues Obviously, you know, it wouldn't take much of a swing, that air to be a little bit colder, that when we see those showers coming in, they could get down to slightly lower levels. But at this stage, it looks like it's just going to be snow on the hills in Scotland. Nothing unusual about that in November. But, you know, noteworthy because it's the first proper kind of cold push that we've seen. And because it has been so mild, it really would be quite noticeable that we'll see that drop in temperature. So that's what the snow is looking like at the moment until Saturday. After that, though, it does get a little complicated. The uncertainty grows. We are pretty happy with the forecast for the rest of this week, up to and including Saturday. But after that, there are more question marks than usual about what happens on Sunday. And to show you that, I am going to talk about a comparison between the Met Office model and the European model. This graph, this map is basically showing the differences between the Met Office model and the European model. You basically take one away from the other. You take the data point away from the other. So basically, if they were agreeing, if they're both saying, say, 7, you take 7 away from 7, you get 0, and that's what the white colours are. You wouldn't get a bit of difference. But if one model is saying 10 and the other one is saying 1, then that difference is 9. Or equally, if one's saying 1, the other one's saying -10, then that difference is shown up here in the different colours. So the blobs of colours, the blobs of the oranges and the yellows, or the blobs of the blues and the purples, are showing where the models don't agree with each other. Now this is the Met Office model taking away the European model at basically high up in the sky where the jet stream is, 250 hectopascals. So it's showing the differences in the pressure pattern up where the jet stream is, and it's showing, this is for T+72, so Friday, that across the UK they're pretty much in agreement. There's no big differences here, but your eyes are drawn to these blobs, these bright coloured blobs. That's where the difference is, coming off the eastern seaboard of the United States. If we go back to the model and what's going on out here, you can see around here the jet is a bit of a mess. That's for Thursday, for today, sorry, and Wednesday. It's really complicated. The jet's kind of splitting in two. There's 2 arms to it, and actually by the time we get to Thursday and Friday, it's how the jet kind of forms this trough, this dip down there, and this low pressure system as a result at the surface. But what the jet is doing high in the sky, it's a bit of a messy one from the Met Office computer model point of view, and there's just not a lot of agreement between the Met Office model and the European model, and that's highlighted here with these differences, those 2 bright colours. And there's quite a bit of difference also across the Greenland ice sheet, and that always adds to the complication for the longer range forecast, because that is quite tricky to model this part of the world. It's a big blob of ice effectively, and so it can confuse the computer models. And when you've got the air coming in from that direction, that is always an added uncertainty to the forecast. If we fast forward to what's going on Sunday, now it's the same thing. So we're looking at the Met Office model taking away the European model at 250 hectopascals, so 250 millibars high in the sky. Now you can see that we've got big differences just to the west of the UK, and actually right across the UK there are big differences as well. So whereas we're pretty happy with the confidence, we're pretty confident in the forecast for the next few days, by the time we get to this time, this is Sunday, there are big differences in and around the UK, and that makes a big difference to the pressure pattern potentially across the country as well. So whereas we've had a nice big chunky high pressure, not really shifting very far for quite a while now, by the time we get to Sunday, what is going to happen? And we can look at what the models are projecting for the jet stream. Let's take a look at what have we got here. This is the European model version of the jet stream. So this isn't one taking away the other. This is just what the European model thinks the jet stream is going to do, driving down to the south and actually generating a little area of low pressure. So we've seen the northerly wind set up for Saturday, but the European model actually wants to then bring an area of low pressure in across the UK because the jet is taking this kind of shape. What the Met Office model is doing, it's got a much flatter jet driving to the south. I mean, essentially they're kind of in similar positions, aren't they? They're driving south in this, but it hasn't got that bend in it, and it's further across the UK, and as a result, the Met Office model isn't generating an area of low pressure, it's just keeping those isobars and keeping the northerly flow going for Sunday across the UK. However, the previous run of the Met Office model from yesterday actually had something similar to what the European model had today. The jet further out in this way, in this direction, it's got more of a bend in it, and that also generated an area of low pressure across the UK. So that's the big question mark. Across the UK, what are we going to see on Sunday? Will we just keep the northerly winds and keep the chilly conditions, or will we actually generate an area of low pressure across the country? That makes a big difference to the potential weather, as I'll try and show you on this map. These are, broadly speaking, the two different possible outcomes. Actually shown this one here, the icon model, the German model, where there's the UK, and you can see we're all covered in the colder air. This is for Sunday. Both of these are for Sunday. The isobars there, you can see them just pointing up to the north, got a northerly flow. This is the European model, which does generate an area of low pressure, and you can see that in there as well. Now, why that's important is because with this one, I'll do some drawing now. You're waiting for this bit, weren't you? You've got the air just coming down from the north, but it's relatively dry air. Okay, yes, it's cold. It's cold enough for some snow on the Scottish hills, as we've seen. And in this kind of flow, on Sunday, it would be chilly everywhere, but actually it's quite dry, the air coming down from the north. And so it would produce some snow showers across northern Scotland, particularly over the hills, mostly over the hills, a little bit at lower levels. But generally speaking, a lot of the UK would just be dry and sunny. This scenario, notice how the low pressure is sitting across the UK, so in which case the winds are going to be going on like this. So instead of the northerly winds, we're drawing in moisture because we're coming in from the Atlantic. So we're drawing in plenty of moisture from the Atlantic, and the air is warmer, so it holds more moisture. One of the reasons why this is struggling to generate much in the way of wet weather is because it's colder air, and colder air can't hold as much moisture. So this is more moist air, and it is a little colder than what we've been used to, but it is still also much warmer air coming in as well. So that is just going to generate much more in the way of rain or in the way of showers. So it's a very different day. In this scenario, it would be cold and sunny across the bulk of England and Wales, and indeed much of southern Scotland, Northern Ireland. In this scenario, it's looking much wetter. The isobars are close together as well. Could be quite windy at times, but the air is that much milder that most of it, if not all of it, is going to be rain. Depending on the position of the low, and there is quite a bit of uncertainty. If the low is a little further south, then there could be a bit more in the way of snow on the hills, for example, across maybe even as far south as northern England, depending on the position of that low. If it's all a little further south, then that could generate a bit more. The colder air would be in, and on its northern flank in here, we would see more in the way of snow falling over the higher ground. So still quite a lot to play for Sunday. Latest thinking is that this scenario is around about 40% chance, and this one is the more likely, but not much more likely, at about a 60% chance. So something to keep an eye on over the next couple of days. It's quite unusual for that split and to have that level of uncertainty, but we are still talking 4 or 5 days away. So yeah, keep up to date with the forecast, because things could get interesting. And if this kind of setup lingers and you get the colder air and you get more wet weather, you get more low pressure systems coming in, that could generate a little bit more in the way of wintry precipitation. But generally speaking, this kind of setup at the moment just most likely to bring some snow to the higher ground, and it's more wet and windy weather for other parts of the UK. But really interesting to see how things develop, and it all stems from that the differences in the computer models high up in the sky, a long way away across the other side of the Atlantic. Okay, that's pretty much it for this week's deep dive. So please do send us your questions, send us your queries. Keep up to date with the forecast as well, particularly as things get interesting. But that isn't completely it, because, as I said at the start, this is a special bonus edition of the Met Office deep dive. A lot of you have been asking questions about ensembles and what they are, basically. So we've been talking a little bit more about them. There's a video which we'll be linking out to, but I also caught up with a Met Office expert on ensembles a little earlier, Ken Mylne, and you can watch that video now. Today we are talking ensembles, and I am joined by ensembles guru Ken Mylne. Ken, thank you for joining me today. Now,
to be here.
Ensembles guru isn't your official title, is it? What would that be? What's your role here at the Met Office?
Well, I've been involved in the development of ensembles as a scientist for over 25 years. When I first introduced the science really into the Met Office's forecasting system, and a lot of that time also thinking about how we use them. And so my job now as a science fellow is to help the rest of the organisation, the whole of the Met Office, to make use of these ensemble forecasts in our products and services.
So you know an awful lot about ensembles, and Ken was instrumental in setting up the video that we made.
Yes.
The what, why and how video, which we'll put a link to in the chat, in which we basically talked around this chart. So what we're going to do today is, it's called the deep dive, so we're going to go into a bit more detail and build up and basically talk about what ensembles are and how they can be useful. So we'll start with a very basic. We'll pare that graphic back and we'll gradually build up. So let's talk us through it.
So this is a schematic which kind of explains how we produce a weather forecast. So we're looking from left to right across the screen in time, and what we're trying to do is build up a forecast for this point in time across here.
Okay.
Now the way we forecast the weather, we start by using a whole lot of observations of what the atmosphere is doing to build up a picture in the computer of what the state the atmosphere is in now. And that's not just here, but that's globally, right around the world.
You can't make any kind of prediction of the future without knowing what's going on right now.
Exactly. And so we get, at this starting time, what we call an analysis, and that is the computer's picture of the starting state of the atmosphere.
Okay.
Now, the traditional way of doing a forecast, what we call a deterministic forecast, is that we take our computer model and that calculates forward in time how the atmosphere is going to evolve and gives us a forecast, a point on this line. So this line might represent temperature or amount of precipitation, rainfall, or
anything really. Otherwise, it's just that one single path. That's
we'll
the
think about it as temperature for now. But
yeah. So that's the deterministic.
So that gives you our deterministic forecast of the temperature. At this time will be
X or Y.
A value.
Right.
Now, what it doesn't tell us is how confident we are in that, how much uncertainty there might be in that. Or if you go back to your school days, what the error bar on that is.
Right, okay, yeah.
So one thing we do know, and this is all we know at this stage really, is what climatology tells us. We know that, for example, here in Exeter, it's November, the temperature's not going to be minus 25.
Yeah.
It's also not going to be plus 30 in November.
Sure.
So climatology puts some limits on it, but that's really all we've got to go on.
Okay.
However, we actually know quite a lot about how good this analysis is, because we know how good all the observations are. And we also know how good our analysis system is. So we've got a pretty good error bar on what that analysis is.
So that's a much smaller error bar than the final error bar.
Yes,
okay, so we've got that.
That's exaggerated here actually. It's really very small, but we know how much.
Well, we can't know exactly.
We can't know
absolutely everything about the atmosphere.
We can never know exactly. So, well, you've heard about the butterfly effect. And the butterfly effect means that a very small error here can make a big error here. So what we do is we make a small number of small changes to this analysis. And that's not just in temperature or whatever, that's in a whole range of different things.
Okay.
And then we run a whole set of forecasts starting from each of those slightly changed, or slightly, as we call it, perturbed versions of that analysis. Right. And then each of those grows slightly different in time because of chaos and gives us a whole set of forecasts at this time. So we can draw what we call a probability distribution, a graph of how likely each of these different temperatures are.
So each one of these is a different path that's generated by a slight tweak in those initial conditions that can end up as a different scenario at the end.
Exactly. And each of those is a complete, consistent meteorological scenario. it's a complete meteorological evolution with storms that develop and everything.
Right, okay.
But they're all slightly different from each other.
And that is in essence an ensemble. So when we talk about running the computer model many, many times, that is what we're doing here. Tweaking a little bit at the start and getting various different futures, different possible future atmospheres that then draw up here. So now you've got a range of possible solutions.
That's right.
How is that useful? People just want to know if it's going to be 10 degrees next Wednesday. How is it useful if you've then got that range of possibilities?
So, well, first of all, it just lets you draw an error bar on your forecast if you like.
Yeah.
But it gives you some measure of how confident you are. We'll come back to that at the end, actually.
Yeah.
But it also lets you draw some other things up. Well, let's add a little bit more on here.
Yes, so we've got the probability distribution.
So, a little bit of maths here. Typical way that we describe a probability distribution, we often talk about the median. That's the middle of, if you take all these samples, the one that's going to be in the middle. And actually, that is a pretty good estimate of the most likely temperature.
Okay.
Notice it's a bit different from what the single deterministic forecast came out of. But that's a useful measure very often of the most likely.
So you've got, I mean, we often run 40, 50 different ones of these. So they're not all the ones on here. We're showing this to keep it because I think there's 10 lines on there. So, but there'd be normally 50, even in some cases 100 different versions. So that's how you build up that distribution of that picture.
Exactly.
And the median is, as you say there, away from the deterministic.
Yeah.
So
but then we can also take, well, if we divide that total thing into 100, so the 25th and 75th are sort of a quarter and 3/4 of the way through in terms of the number. So that gives you a sort of estimate of a central error bar, if you like. Or if you want to really make sure you're sort of taking account of even the more extreme possible scenarios, you can use, say, the 5th and 95th percentiles, which will give you then a really broad picture and a better chance of making sure you capture the extremes. So, and if, just to give one example, if you are well, supposing you, Alex, you're talking about on one of those hot days in summer where we think the temperature's going to, one or two places are going to get really high temperature. We can't necessarily pin down exactly where it'll be, but if you look at the 95th percentile, it'll give you a good measure of what the highest it might be at any one place. And so you could have on your most likely temperatures on your map the 50th percentiles, the most likely temperatures. But you can then say, but somewhere is likely to get this, the 95th.
They're the realistic extremes.
We don't know exactly where it's going to be.
And that's useful for lots of different scenarios, again, as we'll talk about in a bit. But it is really useful. We often talk about, people just want to know if it's going to rain or not. But you can still generate that from these kind of forecasts. But it's also good to know those uncertainties so that people can make judgment calls depending on what they need to know the weather for.
And rain is actually a really good example because you see many days where, particularly if it's a showery day, one of these days you talk about sunshine and showers. And actually we know sometimes it's very variable and it's very difficult to pin down exactly where those showers are going to happen, particularly the big thunderstorms and things. But so it's useful to have it's most likely you're going to get 5 millimetres of rain. But you could get 25, and that's going to be important.
Yeah, absolutely. Okay, so that's the broader picture, and then what are we looking at here? So
I mentioned earlier that each of these is a completely valid scenario evolution of the atmosphere. And sometimes it's actually useful not just to look at that distribution of what's the range of possible temperatures or whatever at this location. You might actually want a scenario, a more extreme scenario. So it's useful sometimes to look at the individual scenarios which are lowest and highest, because then you can tell a complete weather story associated with that member.
Okay, so you get the absolute extremes within those possible scenarios.
So that's a different way of looking at the same thing. Well, the other thing, and
more maths now.
Yeah, more maths. If you're interested in whether we're going to get over a particular threshold, say, for example, talking about heat waves again, that 40-degree threshold, a couple of years ago when we got 40 degrees, you can look at some threshold, like 40 degrees temperature on here, and this will tell you what is the probability, the area under this graph of being above that threshold tells you the probability of exceeding that
You
threshold.
can actually put a number on it, so that's
Yes.
really useful. Historically, in the past, we've not been able to necessarily do
so
that.
we can't say we're
we'd
definitely
kind of
going to go
have
over
an
40
estimate.
degrees.
No, but there
we
is
can
a-
say that there's, say, a 20% chance, a 1 in 5 chance that you are going to get over 40 degrees.
So again, it's actually putting numbers to that
exactly.
general weather forecast. whereas
Exactly.
Historically, that might not have been, oh, yeah, we think there's a good chance, but actually you can now put a number on it.
Yeah. But one of the really big powers of the ensemble, because we could get a lot of this stuff just by looking at the statistics of how good or bad forecasts have been in the past.
Okay, yeah.
And we keep those statistics, of course. We
Yes.
measure them all the time. But the real power of the ensemble that is here is the same thing on another day. We've got the same sort of uncertainty in the starting condition, but this time they've all stayed closer together and we've got a much narrower distribution. So we can be more confident about all the forecasts, more confident of what the temperature is going to be. And this is one of the real powers of an ensemble, is that it's able to forecast the day-to-day variability in that confidence.
So it gives you that confidence in the confidence.
The confidence in the confidence, yeah, absolutely. Yeah.
How happy you can be with the forecast. And obviously, you know, these are much more closely bunched around the deterministic as well.
Yeah.
And it just, right, over the past run, you can see how it's narrowed down. You often get that, don't you, with time. The bands will narrow down as you get closer to the time as well. So you can have that greater confidence.
So
in
it means
the
on
forecast.
this particular day, you could stand up in front of your television camera and say, we're really confident this is going to happen. Another day, you might have to be hedge your bets a bit more.
That's where you come in and you say things like, you know, please stay up to date with the forecast because we're not as confident. I mean, there's a good example at the moment. So that's something that really you can take on board as a presenter and communicating that because you've got that extra bit of knowledge that you can only get from ensembles.
Exactly.
Excellent, excellent explanation. And a reminder, there's a whole other video on this, which we will put a link to in the chat. But let's talk a little bit more about, maybe about uses for them. Should we talk about the uses for ensembles? And we've got a few examples here that we can talk around. This is probably the most obvious one, perhaps, or the most familiar one, perhaps, to people that are.
Yes, and we've done a lot of work on this recently. Some of your viewers will be aware, if they use the Met Office app or the Met Office website, that we were recently trialling some new data on that, and that is now the standard way we present, we drive these, and this is using the ensembles much more than it was in the past. And so, for example, this is a snapshot from our app, our phone app, and well, first of all, you've got the temperatures here, and the temperatures here, whereas before they were just taken from pretty much from a deterministic model output from the latest run of the model, these are now taken, as I was describing a minute ago, from the median of the ensemble. So on those occasions where actually the deterministic forecast is a bit out in the wings, this is going to be more central and more likely to be correct. So these are, so that's really exploiting.
When did that change? That change happened this year.
It was earlier this year. Yes. Yes.
Okay, and then we've got the percentages of precipitation.
And yes, the percentages of precipitation likelihood at the bottom. Now, we've had those on the app for a long time, but we've completely changed. These are now calculated directly from the ensemble and using a bit of clever post-processing as well to make it even better. And actually, that's the single thing which has improved the most in quality with the new version of the app. The probability of chance of rain has improved a lot.
And a good example of how we're introducing ensemble forecast, but most people aren't actually necessarily noticing because it's just kind of being embedded within things that we already have.
The app still looks the same. We're still essentially showing people deterministic forecasts here. But the quality of them is better.
Because of the ensembles. Okay, now this is something that I use and the chief meteorologist uses here quite a bit at the Met Office. This is really, really useful for visualising the chance of certain types of weather happening. Talk us through what we've got here.
Well, this is actually coming out of the same system I just mentioned, which is driving the new app. It's a post-processing system which takes the output from the ensembles and does some more clever stuff with it and calculates probabilities and things very as accurately as we can. And actually, for some things, it does a bit of calibration as well, looking at how good things were in the past, using the observations and making some further statistical corrections. But that's probably more detail than we need. But so this example here, this is looking at the probability of fog of visibility falling below 100 meters. And so the colours here are not showing you what the visibility is going to be. It's showing you how likely is it that it's going to be less than 100 meters. And so you can see immediately that Ireland here, we've got very high probabilities at this particular time, and I think this was this morning, wasn't it, of fog visibilities. And then up in Scotland, particularly up the west of Scotland and into Wales and things, we've got probability of fog, but not as high as it was in Ireland.
So there is a chance. And
yeah,
again,
definitely a chance of fog. And
it's as opposed to across the east, where there's
much
less probability. Yeah. So again, it's informing people, giving them more information so that they can make decisions based on this information.
Exactly.
So if whether the fog is a big player for them or not, depending on whether you want to allow an extra hour or an extra bit of time for your journey to work based on how quickly you've got to get there based on this information.
So take the train instead of driving or something like that.
Yes, even better, even better. So that's a really good example, really useful tool for us meteorologists. But I think in the future we'll be able to display that more obviously to the public as well.
Yeah. Yeah.
What's this showing? We've shown these before in deep dives as well. This is kind of a plume or showing temperatures higher in the sky, but it's useful to kind of get trends from this.
So it's really another way of showing the same forecast for a particular thing, and in this case it's temperature, and it's a little bit like the schematic that I showed you actually, because you've got a plume of the different members of the ensemble, these rather faint dashed lines in the background, but the colour shading is also showing you how they're clustered. So the darker the colour, the higher the probability it's going to be in that band there. So here you've got your sort of central most likely value, and then the pinker colours are showing high probability the temperature is going to be there. But you can also see the full spread of what range the ensemble might be telling you.
And again, you get different ones. So so if that sort of green tube is closer to the dark pink, you have that greater confidence because there's less spread. And obviously, as you get further in time, generally the spread is larger. But I've seen these ones where there's a lot of confidence because it's rock solid that it's going to be.
That's right.
And then it suddenly spreads because there's a big perturbation.
So
in the forecast.
it's a really nice illustration just of how, because of chaos, the uncertainty grows as further away you go. The other thing that can happen with these, not really happening in this one, but occasionally you can get a collapse back again, returning confidence. And that might happen because you've got, say, the passage of a storm or something that's a bit uncertain as to when it's going to go through, but high confidence it is going to go through, and so after it's gone, the confidence comes back again.
Yeah, and we've talked about that again in the deep dive and the 10-day trends. About it seems counterintuitive, but sometimes you can have more confidence in the forecast at day 6 and 7 than you can for days 2 and 3. So sometimes, again, it's just that variability within the meteorology. Really interesting stuff. What's this and how's this used? We've used this in our 14-day outlook sometimes, but
so one of the things that we can do with an ensemble is what we call clustering. So we've got all these different scenarios, but we often want to try and summarize that because there's far too much information.
Yeah.
And so what you can do is use an objective mathematical way to try and identify different members of the ensemble, which are actually rather similar to each other, and cluster them together, and then produce a kind of summary of, well, if this cluster comes out right, then this is sort of the average conditions you're going to get given that cluster. And that's what this is showing. So this is from a clustering thing, cluster number 1, and it's showing the ensemble mean, the average of all the members that are in that cluster. So we've got clearly here, all these members are showing a big low pressure system up in Scandinavia, well to the north of Scotland. So you've got a westerly flow over northern Scotland. Really high probability there's low pressure down in to the west of Spain. And the other thing, all the numbers on here are showing the measure of the temperatures given that scenario.
And there's more information over here. So that's 61% probability
Yes.
of this scenario. So that's using how many of
How many
the
members
ensembles are within this kind of
within that
broad
cluster.
pattern.
Yeah.
61%, obviously that's quite a high chance that this will be the weather pattern. It's not telling you individually what the weather's going to be like,
No.
not giving you a cloud cover, but with high pressure like that, it's much more likely to be dry here and wet and windy across northern Scotland. And that's really useful for those medium to longer range forecasts.
Yeah.
So that's another use of it. And then this is...
So this is a really nice one. Now this doesn't apply in the UK very much because we don't get hurricanes and tropical cyclones, hurricanes, typhoons and things in our part of the world. But what we're doing here, this is for a typhoon approaching the Philippines. It's starting out here, and in every member of the ensemble, we are calculating what is the track over the next few days of where that typhoon might go. And you can see it, same sort of thing, starts quite narrow, and then as further ahead you go, the more they spread out. The different colours here represent days ahead.
Different 24-hour periods.
Yeah, that's right.
Yeah.
So you've got then a range of the places that the hurricane might go and therefore affect. Again, this measure of how confident can we be in where it's going to go. And
if it's very narrow, then you're more confident.
If you watch these on a regular basis, they're very interesting.
Yeah, they are.
So they really do. Sometimes they all bunch very close together, and then other times they can go. You might have one that's shooting off here, and that's all just depending on what's happening in the upper atmosphere, which is what steers these things. Yeah,
but again, really, really useful for planning and for people to be at least aware of the risk. What is the risk where you are of being hit by a tornado or a cyclone? And you can actually put numbers on that, and that's really useful for people prepping. Okay, it's only a small chance that we're going to get hit. We'll maybe make a few calls, but we're not going to go into full lockdown mode yet. Or there's a high chance, a really high chance that this storm is coming our way. In which case, you need to start evacuating people and making preparations for it.
Hurricane evacuations need to be started 2 or 3 days ahead because it takes a long time to evacuate a city like Miami or something like that.
Yeah.
So you need to take early preparations. So there's often still some uncertainty when you're that far ahead, but it gives you a good idea of
confidence.
Making those decisions with a good understanding of what the likelihoods are.
It's about making informed decisions.
Exactly.
It's about making those informed decisions, having as much information as possible. Yeah. Now, this guy's good. I've seen him before. He's really good. What are we talking about here?
So this is actually taking the same sort of thing and applying it here. We don't get hurricanes, but we do get winter storms. And sometimes we have similar sort of uncertainty in the track that those storms are going to take. We actually have another tool which allows us to track those storms in each of the members of the ensemble and produce a similar sort of picture to what we just saw. They're a bit more complicated because we have lots and lots of the storms around. And that's what you were showing here is 2 alternative tracks for a low pressure system, and then talking about the impact that was going to have in terms of where the snow was likely to be in this particular case.
So there's a 30% chance of this happening or 70% chance of this happening, and talking through those potential risks. So again, it's about informing the public so that they are fully aware. Again, not necessarily that useful for everyone, but it's really useful for people who are planning and people who need to know about these events higher in time. Do you need to call more people in on shift to be prepared for this potential weather event? Do you need to start cancelling trains? And it's all based on those probabilities. So again, really, really useful use of ensembles. Yeah. What have we got here? Now this
looks horribly complicated. Actually, in a sense, it's showing the huge amount of information that we have in Ensemble, and quite baffling actually for an operational forecaster or whoever to look at all this information and try and extract it. Which is partly why we summarise things in
those clusters
as clusters or as probabilities and things.
Yes.
But people who've looked at the other videos might have seen this before.
Yeah.
It was the ensemble forecast for the Beast from the East storm that we had a few years ago. And the colours here are showing a rate of precipitation, but in this case it was all snowfall. And the Beast from the East itself was this strong easterly flow coming across the North Sea and peppering all of the east coast of Scotland and northern England with snow showers, which accumulated loads of snow over a period of time. And you look at every single member of the ensemble has got that picture, so we can be really confident about that strong easterly wind and those snow showers all up and down the east coast. But the other thing that happened And this was a 3-day ahead forecast. The other thing that happened then was that we got a new low pressure system that spun up and came up into the southwest of England. But this 3 days ahead, we've got a few ensemble members. Well, that one's taken across the southeast rather than the southwest. But we've got a few ensemble members which have brought snow showers into the southwest. Yeah. And quite a lot of others which didn't. So 3 days ahead, we were looking at the possibility of a really big dumping of snow in the southwest of England. But we couldn't be sure because this is what was happening. So we were, well, I think, have you got the probability map?
No, not for this one.
Okay.
Not for this one. But it's really useful to show that some of them have it dry, but a lot of them are showing that symbol for something coming up to the south, and that's the key, isn't it?
It absolutely is, and it allows you as a presenter to talk about the risk of this heavy snow in the southwest, but we can't be certain yet whether it's going to happen or not.
And of course, if you just used the deterministic, if you just use one model, if that happened to be
it could
the
be
one that doesn't have any snow in it,
it could be pretty good, or it could be completely wrong.
Exactly, that's the thing. That deterministic doesn't give you it's black or white, and that's not really useful in this kind of situation where you're just not sure. But to have some inclination that it might happen is really useful to start the prepping, to tell people to keep up to date with the forecast. And
one of the ways that this was used here was that we were able to issue, I think it was initially a yellow warning for the southwest, and then upgrade that to an amber warning. And then as we got closer to the event, then they all started converging and gave high confidence of that snow event. And so it was, I think it was raised to a red warning for the southwest. But it allows us to give that early alert through a yellow warning, and then we can, as we get closer to the event, we can either say, oh, well, that's not going to happen. So occasionally you'll see a yellow warning, it'll just be taken down.
Yeah.
But other times it gets ramped up to an amber and a red, but people have had some early warning to start being prepared.
It comes with that confidence, and that's, again, anything you get with ensembles. One question we're going to get asked a lot is, how do you mix up those initial conditions? We talked a little bit about tweaking the pressure here, changing the temperatures there, but it's quite a lot more complicated than that, isn't it? I think this graph should help to show that.
Yes. So what we're showing here is, again, going forward in time, and we're generating the new starting conditions for this time here, 9 o'clock in the evening. And we don't start from scratch. We've got a previous forecast. And in fact, we also use that in creating that analysis, the starting condition for the model.
Start over every time.
We don't start over every time, but we combine the previous forecast with the observations to create the new starting conditions. But we do the same from the ensemble. Now, here's the old ensemble, and it's evolved and the spread's grown quite a bit. And we know that the uncertainty at this point is much less than that. It's constrained by the observations. So we shrink that spread. So each of the perturbations we take as the difference between the average and the individual member.
So it's a continuous cycle.
Perturbations are difference. We shrink those differences back to the typical sizes of the analysis errors, and then we add them back to the analysis to get us a new set of a smaller spread of new conditions.
And so it goes on.
And then it goes on in future.
It shrinks back down again.
And that's the chaos working.
Okay. And what have we got here?
So that's a very vague picture how we change the initial conditions.
Yeah.
But actually, we also know that the model is not perfect in the way that it represents how the atmosphere evolves. It actually does very, very well on the large-scale flow and what we call the dynamics of the atmosphere, how the winds and the pressure systems develop and all that sort of thing. But it works on a grid of points.
Yeah.
And those points, well, in our global model now, are 10 kilometres apart. There's actually quite a lot happening inside those boxes.
Quite a lot of weather goes on in 10 kilometres.
So this is just a picture of a grid box within the model. And for example, this might be showers, rain showers happening within that grid box. Or there's also turbulent motions, gusts of wind and all that sort of thing. Small scale things that the model can't represent.
Because of the grid size is too big and they're smaller than... So
we have little models, if you like, within the model, which represent statistically what's going on inside here. But it's a statistical average of what's going on inside these grid boxes.
Okay.
And so what we do is that we actually perturb those as well while the model's running and produce, because this produces outputs which feed back up into the larger scale flow. It actually triggers chaos. Little differences in what's going on in this box make small differences back onto the large scale flow, and then chaos means those can grow in the future.
My brain's hurting already. It's good that we've got a supercomputer to do all this.
Very definitely a good thing.
That is why we need one, absolutely.
Well, it is, and actually Ensembles now are the biggest consumer of the power of the supercomputer.
Another question we're going to get asked a lot, Ken, is if you use probabilities, you can never be wrong. Right? So
Yes.
that's what always people say, don't they? Well, if you say it's 70, then you can never be wrong. But actually, we know that ensembles are more accurate than deterministic forecasts.
Yes.
What's the process involved with that?
You're quite right. It's one of the questions I get asked, or accusations I get more than anything. You're just trying to hedge your bets to make sure you can't be wrong. And there's a certain truth in that. As long as we don't say 100% or 0%, then yes, we can't be wrong. Yeah, well, but we can. Because if we say something's got a 30% chance of it happening, and we take lots and lots of times that we said 30%, and we look at how often within all those times it happens, it should happen 30% of those times. So you can measure that. And you can do it also for 40, 50, 60, 70% as well. And that's essentially what we do. Now this is an illustration. We've got here, I'm not going to go into the details of how this particular verification works, but it's like what I just described, but it's looking at all those different probability thresholds. So we can use that over many forecasts to measure how good these probability forecasts are.
It's a lot of data, haven't we? We've got a lot of data to verify.
Now what we're doing here is something a little bit clever, is that we're doing that both for the deterministic model and for the ensemble. The deterministic model's in blue and the ensemble in red. I won't go into detail of how we do it for a deterministic model. We can generate probabilities sensibly out of the deterministic model as well. And
the red is tracking above the blue. So
yes, we've made the effort here to treat both fairly and equally, and higher is better on this graph. The very jaggedy lines up and down are the monthly scores. These are averaging through that over time. And you can see that very consistently, the ensemble in red is performing better than the deterministic model in blue. This one's for precipitation. Over the right-hand side, we've got temperature and wind speeds, and it's doing the same thing. And this is a very consistent picture across lots of different ways we measure how good the forecasts are. As a result of this is really the big driver behind us deciding the big change that we're going to make in our modelling over the next year. Do you want to move on to that other slide?
Yes.
So this is the main modelling systems that the Met Office runs at the moment. We have a global model, which we run a single realisation several times a day at 10 kilometre resolution. That's the size of the grid boxes.
Yeah.
And an ensemble we run at 20 kilometres with 36 members in it. Similarly for the UK, we do a single run at a 1.5 kilometre box size.
So it's higher resolution, more accurate in theory, because it covers the UK.
Just over this area here.
Obviously it takes more processing power, so you can't do that across everywhere. So we focus on the UK.
And that's often the pictures that you show on the television from that model. And we run an ensemble at slightly lower resolution at 2.2 kilometres.
That's what we do now.
That's what we do now, but because of the verification I showed in the previous slide, we are actually getting away from that. We're stopping running a single higher resolution deterministic model, and we are just going to ensembles. For the UK, we're raising that resolution up to the 1.5 kilometres, the same as the deterministic is at the moment. And for the global, doing the same thing, we're running the global ensemble at 10 kilometres.
What's the time scale on this?
This is coming in on our new supercomputer in 2026, hopefully. If everything goes to plan, it's coming in 2026.
And that should provide more accurate forecasts, more detailed ensembles, more frequent, higher numbers of members, so giving you better data.
Well, initially it'll be the same number of members, but in future, the sort of improvements we'll be making in the future will not be running a higher resolution deterministic, but doing things like increasing the number of members in the ensemble. And when we can afford to, increasing the resolution of the ensembles themselves. But really big change. We've been running those deterministic forecasts for 40, 50 years. And suddenly now we're only going to be running ensemble forecasts. That's a really big change.
Quite a big shift. Again, a lot of the forecasts that people see, you won't necessarily spot the difference, but
no, that's right.
they're not going to look really any different or feel any different because the way that we can make them seem similar.
Yeah.
But they will be more accurate and they will give you more data, more information, and help people make better decisions.
Exactly.
That's the plan.
Yeah.
Good stuff.
And over time, we are planning to start bringing in a few more other products, additional products as well, which are making more explicit use of the ensembles.
Excellent. So we'll have you back to have more discussions
Absolutely.
about ensembles in the future. But I hope that was interesting. I was fascinated. I learned an awful lot, Ken. We had a lot of questions about ensembles because we talk about them a lot in the deep dive, the 10-day trend. So for you to explain them here in such detail is really, really helpful. Thank you very much. Yeah, if you've got any questions about ensembles, then do put them in the chat as well, and we can always get
try and answer them.
And we'll try and answer them. But for now, Ken, thank you very much.
Thank you, Alex. It's been a pleasure.
Cheers. Huge thanks to Ken for coming in and filming that earlier, and huge thanks to you for sticking with this extra special, extra long Met Office deep dive. Thank you very much for being there. Do let us know if you like that kind of thing, if that's the kind of level you want us to go to. If you're interested in any particular aspect of meteorology, then again, do drop us a comment and we'll try and cover that. There is another video that explains why we use ensembles, what they are, and how we can use them, and you can catch that by clicking on here. And don't forget, Weather Studio Live will be back on Friday, and on Wednesday, Aidan will have the Met Office 10-day trend. Thanks for watching.